Today we will study the expenditure function. We will have to study the function of utility, which should be maximized and with the given level of expenditures, which should be minimum. So whenever we are concerned with the expenditure function, what we do is that we derive from the problem of minimizing the total expenditures which are necessary for the consumers to achieve a specified level of utility. Okay, now these expenditures should be minimum, and okay, so the expenditures should be minimum in order to achieve the maximum level of utility. This is started in the expenditure function. Therefore, through this statement, what we will do is that we will have the function where we will have to minimize the, okay. So now our function is minimize summation Pixi, which is subject to these two conditions. The first one is the utility function, utility derived from the conditions of x1, x2 till xn. And this utility derived from all these consumption of all these commodities should be greater than or equal to u. And the second constraint is that all the xi's, that is x1, x2 till xn, they should be either greater than or equal to 0. They cannot be less than 0. So therefore, our function is minimize x1 till xn are the consumption of commodities, okay, given the price of each commodity and consumption of each commodity, subject to these two constraints. The first one is the utility derived from all these goods should be greater than or equal to the u function, the utility function, and all the goods that are consumed, their values cannot be less than 0. They can be greater than 0 or they can be equal to 0. Now, if all the prices are positive, then the condition in this A1 is satisfied, okay? So therefore, all the prices should also be positive. Prices can also be not equal to, they cannot be less than 0. They can be equal to 0, but they can not be less than 0. Now, next is we have Lagrangian function, okay? Now, in this Lagrangian function, we have summation Pixi, okay? That is, which was our main function, summation Pixi plus. We always multiply this lambda with the constraint function. And because of this, we get the Lagrangian function. Therefore, what we will do is that we will multiply lambda with this function. That is, we rearranged this function. We brought this whole term on the right-hand side, and therefore it was subtracted with it. And we got u minus u into x1, x2 till xn, okay? Okay. Xn. So as this is a constraint function, it is multiplied with lambda. And when it is multiplied with lambda, then what happens is that we add it with our main function, that is our objective function. So therefore, the Lagrangian multiplier function is L is equal to objective function plus the function that has been multiplied with the constraint function that is multiplied with the lambda. Therefore, it is summation Pixi plus lambda into u minus u into x1, x2 till xn. Now, as we have already studied, or we are aware of the first order condition and second order condition, why do we use the first order condition? We use first order condition in order to find out the critical values. That is the values of x or the values of p's. So therefore, now we have more, this I represents the value of commodities starting from 1 till n. So therefore, we have more than one commodity over here. And for that purpose, in order to utilize the first order condition, what will we do is that we will take the partial derivatives. Curly L upon curly xi is equal to, by taking a partial derivative of this Lagrangian function with reference to xi, what happens is that this xi will become equal to 1, okay? And what we will be left over here is pi. Then we have plus lambda u. Now there is no xi in this function. As there is no xi in this function, this whole function will become equal to 0. Therefore, curly L upon curly xi is equal to pi plus 0. Now, what we have next over here is, again, Now x1, x2 till xn, this whole is represented by collectively by xi. Therefore, this is also lambda u xi. So therefore, when we take its derivative, this xi will become equal to 1, and 1 will be multiplied with lambda and u. Okay, therefore it is now minus lambda ui. By solving it further, or by removing this 0 from this derivative, we get pi minus lambda ui. Therefore, we have named it as equation number A3. So now let's move forward. The first order condition always states that you have to put this derivative equal to 0. This is the requirement of first order condition, that when you take the derivative of the function, you will have to put that equal to 0. Therefore, curly L upon curly xi is equal to 0. By putting it equal to 0, what we will get is, we will get pi minus lambda minus lambda ui is equal to 0. Now, what would be our second partial derivative? Our second partial derivative will be lambda, curly L upon, it will be curly L over curly lambda. Now we can see that if we take the derivative of this function, we can see that over here there is no lambda, so therefore this whole term will become equal to 0. Lambda is multiplied with u and u x1, x2 till xn. That is, it is multiplied with u and u xi. So therefore, the first value will become equal to 0. Then we have plus lambda u. And when we take the derivative of lambda u, we are taking it with reference to lambda. Therefore, what will be left over here is this lambda will become equal to 1 and u will be multiplied with 1. Therefore, the next one will be plus u only. That is, in place of lambda, the derivative has become equal to 1. Then we have a negative sign over here. This negative sign will come at its own place, okay? And lambda is multiplied with, now lambda is multiplied with u and x1, x2 till xn. Therefore, this lambda will again become equal to 1, and what we will be left with is u and x1, u multiplied by x1, x2 till xn. So now we will write it as, okay, it will become u into x1, x2 till xn. Now again, we know that we are concerned with the first order condition, and when we are concerned with the first order condition, what we do is that we will put this partial derivative also equal to 0. Therefore, curly L upon curly lambda is equal to 0. By putting it, okay, let me write it. Curly L over curly lambda is equal to 0. That means u, it implies that u minus u into x1, x2 till xn. You can also write xi over here, or if you want to write it completely, there's no problem with this. So u into x1, x2 till xn is equal to 0. Now this will be referred to as equation number A4. Okay, this is A.4. So now let's move ahead. It will yield values of lambda. Now this equation and this equation, this one will yield the value of lambda, which will help us to solve for xi. That is, how will it yield the value of lambda? We will solve both of them. We will equalize them to each other. That is, it will become pi over pj is equal to price of good I with reference to price of good j is equal to utility derived from good I to the utility derived from the good j. Okay. Good j. Okay. Now the ratio of the prices is equal to the marginal rate of substitution. What is this ratio showing? This is showing the marginal rate of substitution. How one good is substituted? how the consumption of one good is substituted in order to consume the other goods. So therefore, this has become now MRS. Ratio of the prices is equal to the marginal rate of substitution. Now let's move ahead. That is, we will study this derivation through a simple diagram. We have again a diagram where we have two curves. On the vertical axis we will take x2, on the horizontal axis we will take x0. One of them is I, the other one is j. Okay. Now we have three different budget lines. The first one is M1, second one is M0, and third one is M2. Okay. This is M0. I'll draw the diagram first and then explain it to you in detail. This is M2, not M1, okay? Because this is the higher budget line and this is the lower budget line. M1. Now what happens over here is we have a substitution also over here. This curve go like this. Now this is, have to be very careful. Let me draw it once again. Yeah. Now this is our now this is our indifference curve. Okay, yeah. So now this is I0. Whenever we are concerned or whenever we are substituting one good for the other good, because of the change in the prices of any of the goods, or maybe both of the goods, then in order to study the substitution behavior, what we do is that we draw another budget line. And therefore, the same isopont is changing to that budget line as well. So now let's make points. Let this be M3. Now this one is x2 raised to power 3, and the central one is x2 now. Okay, x2. Okay. So now this I0 is showing the combinations of x1 and x2, which gives us the utility level of U. Okay, the goods that are consumed by the consumer are shown by this indifference curve I0, which are showing combinations of the goods x1 and x2, which is giving the utility level U. Now feasible set is all points on or above the I0. What is the feasible set? Feasible set is all the points on or above this indifference curve I0. M0, M1, and M2 are ISO expenditure lines, which are similar to budget lines. Okay, this is M1. M0, M1, and M2 are referred to as ISO expenditure lines, which are similar like budget lines. Now the problem over here is to find a feasible set which is on the lowest ISO expenditure line. Because we're concerned with the expenditure function over here, what will we do over here is we want to find out the feasible set which is on the lowest ISO expenditure line. Now the equilibrium point is where ISO mean difference curve is tangent to the budget line or the ISO expenditure line. Therefore, the equilibrium point will be tangency point of I0 on the M0. Okay. There are two main problems over here which we will study. Okay, let's study this diagram. And there are now two problems over here. The problem containing all utility maximizing consumer is to move along budget line until highest indifference curve is reached. Now, the first problem is that the utility maximizing consumer has to move along the budget line until the highest indifference curve is achieved. Consumer will choose that budget line until the highest indifference curve is achieved. That is, maybe at this indifference budget line, consumer cannot reach because he cannot afford this level of consumption. Okay, so therefore, at the moment, the highest indifference curve is the indifference curve I know. So therefore, the consumer has to move along that budget line. Over here, we have M naught at the moment where he is achieving the highest level of indifference curve. The next problem is containing the expenditure minimizing problem. That is, it is to move along the indifference curve until the lowest ISO expenditure line is achieved. So therefore, what happens over here is that second problem is concerned with the problem of minimization. That is, the consumer has to move in such a way that until the lowest ISO expenditure line is reached. Again, let me move back to our initial statement. When we started this topic, we had a condition where we wanted to maximize the utility. In order to maximize the utility, consumer should be on the highest indifference curve. Then in order to minimize the expenditure, the consumer should be on the lowest ISO expenditure line. So the same statement has been repeated over here in this diagram. So therefore, optimal X star. Optimal X star, it depends on the prices and utility level. We said that Xi should be greater than or equal to 0. Okay, good. We said that Xi should be greater than or equal to 0. For that case, now we know that the Xi should be either greater than or equal to 0. That was what we assumed at the start of this topic. So therefore, the optimal X star from any of these Xi's, it depends on the price and utility level. Therefore, the Xi, okay, therefore the Xi star is equal to Hi, okay, Xi star is equal to Hi into, now it is the function of P1, P2, the prices of the goods that are consumed by the consumer, P3 till Pn, and also it is the function of the utility derived from the consumption of these goods. That is, Xi star is the function of the prices of the goods X1, X2, X3 till Xn, and the utility derived from the consumption of these goods on which the expenditures are made, which have been shown by the price levels. So therefore, in order to simplify it further, we get it in this form, that is Hi into Hi into P and U. Now this Xi star is the function of prices and the utility. Now this H shows that it is the Hicksian demand function for Xi. Now what will we do is that we will substitute the optimal values of Xi, the optimal values of Xi in the function summation Pi Xi. That is, okay. Therefore, we will have a sum because we had to maximize this function. This was the start of topic. So we will optimize, we will substitute the optimal values of Xi in this particular function, that is summation Pi Xi star. This will now become equal to summation Pi. Now we know that this Xi star is equal to Pu, okay? That is, we elaborated it over here, and then by simplifying it, we get Hi into Pu. Therefore, what happens over here is that in place of Xi star, we will substitute Hi into Pu. That is, we will substitute the Hicksian demand function. Therefore, it will become summation Pi Hi to Pu. Now again, by further simplifying it, what we will get is that we will get the expenditure, ISO expenditure line N with the PU. That is PIHI represents the ISO expenditure line, and therefore it will become summation PIXI star is equal to M into PU. Now let us name this equation as A.7. Now this function that is MPU, it is the expenditure function, which is showing the minimum level of expenditures to achieve a certain level of utility. Fixing demand function, just one. This is also known as compensated demand function due to change in the price. Okay, as a result of changes in the price and the demand with the utility held constant. If there is an increase or decrease in the price with utility held constant, what happens is that we automatically make changes in the expenditures that are required to compensate for the effects of price change. It is known as compensated demand function. Why? Because if the price increases or decreases where the utility is held constant, then we are required to compensate for the effect of price change on the real income of utility. Let me be more specific for this. Suppose that the price increases of any good, okay, or we can say that the price of a good decreases. Now, why is this known as Higgs's demand function is known as compensated demand function? Because even if the price increases or decreases, the utility remains the same. That is, it does not increase or decrease. So therefore, as a result of change in the prices, what we will do is that we have to compensate for the effect of the price change. Because of price change, the utility will neither increase nor decrease, it will remain the same. We will have to compensate this change into the in such a way that the utility remains the same. So therefore, the figure that which we have studied now, that is, let me go back to the figure. Okay. Therefore, the figure 3.1, in figure 3.1, let P2 remain constant. That is, let the price of good X2 remain constant. What will happen over here is that because of the constancy of the prices of the good 2, the second condition is that the price of good 1 falls. That is, P1 will decrease. Okay, which will generate new family of ISO expenditure lines with slopes corresponding to that of M3. Okay. Now what happened is that over here, the price of good X2 has remained constant, whereas the price of good X1 has decreased. When the price of good X1 has decreased, it means that the consumer can purchase now more of good X1 and the price of good X2 has remained the same. So therefore, what happens is that we will get another ISO expenditure line, which is M3. Then we will get M3 in this case. So now X1 is new expenditure minimizing consumption bundle. Our expenditure minimizing consumption bundle will change. And therefore, it will change from X star to X1. Okay. Earlier, if it was. Now, this was the initial equilibrium position, that is X star. As a result of change in the price of one of the goods, not both of the goods, what happened was the ISO expenditure line changed, and because of change in the ISO expenditure line, the equilibrium position has also changed. Therefore, X1 is the new expenditure minimizing consumption bundle, and it changes from X star to X1, and it is the effect of making relative price change with M varying to keep the utility constant. In order to keep the utility constant, substitution has been made. Consumer has moved from X star to X1, that is, he has remained on the same indifference curve. His indifference curve has remained the same, it has not changed. Therefore, the consumer has compensated for the price change by remaining on the same indifference curve. Now, after this topic, we will study the properties of expenditure functions. And in order to understand the properties of expenditure function, you should understand this topic first, the one that we have studied just now. Thank you very much.